wonder how they make rock candy? Rock candy is sucrose, cane sugar, that has been crystallized into great big gigantic crystals. And the technique that they use is something called a crystallization. And I'm going to demonstrate the technique of crystallization for you using acetylsalicylic acid, which is the active ingredient in aspirin. And the crystallization is a way to purify a compound because the crystals form in a very pure form. What I have here is 5 grams of acetylsalicylic acid. It's a white solid, and it's microcrystals. They're little tiny crystals. And the technique involves dissolving this acetylsalicylic acid in water. But what we're going to do is we're going to dissolve it in water at its solubility limit at high temperature. So in other words, we're going to put it into a beaker and add some water, and we're going to heat the water up, and we're going to add just enough water until it's saturated at the high temperature, at 100 degrees C. What does saturated mean? That means that the absolute maximum amount of acetylsalicylic acid has been put into the water, and there's no solid present, okay? Now, in order to make this more interesting, so I could do that. So I could take this and warm it up on the hot plate here until the water is boiling, and just keep adding little bits of water until I get exactly to the point where I've added just enough water to dissolve everything and no more, okay? So now, to make it more interesting, what I'm going to do is add some food coloring to this solution, okay? And think of the food coloring as some sort of impurity that might be present in the aspirin. It doesn't have to be food coloring, but the point is I can do this. I can add food coloring to this mixture. And so now, not only do I have a mixture of acetylsalicylic acid and water, but now I've got food coloring as well. And again, I'm going to add enough water until it is fully dissolved, but we're right at the solubility limit. And I've done that already here, okay? This is a a beaker in which I have dissolved acetylsalicylic acid. You can actually see there are little bits on the outside, so I might have to add just a little bit more water. But this was, again, 5 grams of acetylsalicylic acid with just enough water to get to its solubility limit. Now, what do? Well, it is saturated at the high temperature, but what happens when we take it off the heat and allow it to cool all the way down to room temperature? Well, it's saturated at the high temperature, but as we cool it down, it becomes supersaturated. Its solubility increases as you heat it up, so as you cool it back down, its solubility goes back down. And when the solubility goes back down, what happens? Well, what happens is the material crystallizes, and that's what's gone on here. This is, again, a beaker that I prepared before, and it's sort of this sludgy mess now that has the food coloring in the water and the crystalline acetylsalicylic acid. Now, the crystals are not as nice as these crystals, but they're still nice crystals, and the point that I want to make is that if we have been able to effect a purification here, then when we collect the crystals, the color, the food coloring ought to go with the water, and so the crystals ought to come out perfectly colorless again, just as the crystals of the sugar are perfectly colorless. So let's take a look. And the way you collect crystals after you do a crystallization is by a vacuum filtration. So here I have a vacuum filtration apparatus. Again, it's a vacuum filter flask with a Buchner funnel and a piece of filter paper that's placed inside there to cover the holes. And we collect by pulling a vacuum on it. So you turn on the vacuum, and then you wet the filter paper, and then you start collecting the crystals. And now what I'm going to do is wash the crystals with a little bit of water. Oh, let me stop it right here and show you what it looks like. Okay, so at this point, what it looks like is it looks like sort of crystals that are pale blue. And why they're pale blue is not because the blue is incorporated into the crystal. Again, the crystals are fairly pure. What it is that the blue is coating the crystals. And so what we're going to do is we're going to take a little bit of water and we're going to rinse these crystals, and we're going to lose a little bit of product. And obviously I could have done a better job of getting the rest of this out of here, but I'm just trying to illustrate the point here. Now we're going to add a little bit of water and wash the crystals. And this ideally would be very cold water because, again, the crystals are not soluble in cold water. But let's do that. And then when I'm done, I'll show you that the crystals are pale or colorless or nearly colorless. All right. So all I did was wash the crystals with some cold water, and ideally I would have used very cold water. But now you can see that the crystals are almost perfectly white. Now, if I'd done this more carefully, they would have been even more white. And if they weren't as white as I wanted them to be, I could have repeated this process again, recrystallized it. I wouldn't add more food coloring because remember, that's the impurity. But if I repeat this process of crystallization, the crystal product that comes out the second time is even going to be more pure than the first time. So what have we done? Well, I've demonstrated the concept of a crystallization where you take a product that isn't pure, in this case the impurity was food coloring, and bring it to its solubility limit at high temperature, and then cool it down slowly, and the material will crystallize, and the crystals will be very pure. And then to collect the crystals, what you do is a vacuum filtration. You could do a gravity filtration, but it's faster to do a vacuum filtration. And the product, once it's washed with a little bit of cold solvent, is typically very clean and very pure. And that's a technique, another technique for affecting the purification of a compound.